Very good morning to all. In this video, just we are going to see about the introduction to graph. So what is meant by graph? What are the different types of graphs are there, and the implementation? Just we are going to discuss. And why? First of all, we should know what is the need of graph. A graph, it is a non-linear data structure. Just this is used to store the data which is required to solve the problems. That problem, it could be solved through the programming languages. Then next slide, in this slide, just we will see the definition for graph. Okay, a graph is a non-linear data structure and it of vertices and edges. Usually a graph, it consists of edges and the vertices. For that, we will call in book definition, it is given as it is a finite set of nodes and the finite set of edges which is connect the vertices. In general form, the equation is for defining the graph is equal to set of vertices comma edges. Then I have given two examples for the graph. One is the directed graph and another one is the undirected graph. The first one is the undirected graph. Undirected graph means the vertices are connected without the arrow symbol. If the arrow mark symbol, it will not be represented. In this, the 0 is the vertices 1 and 1 is vertex 2. These two vertices are connected with the help of edge, the dark line. Okay. If you consider in this graph one, the vertices are 0, 1, 2, 3, and 4. So there are 5 vertices in this graph one. And the edges, okay, the edges is nothing but the set of edges. The 0, it is connected with 1 and 2. So it will be represented as 0, 1 and 0, 2. And the 2 is connected with 0, 3 and 1. So the edges of this 2 vertices 2 are 2, 0. It is already mentioned as 0, 2. So don't include this. Just we have to include 2, 3 and 2, 1. And the next one is 1. The 1 vertices 1 is connected with 2, 0, 4. Okay. This 2, 1 is already there. 0, 1 is also there. So next we have to include 1, 4 alone. Next, if you consider 3. 3 is just connected with 2. This also it is represented. Okay. So next one is the directed graph. In this directed graph, the directions will be given. So based on the direction, we have to move. Okay. So based on that only, you have to write the sets. Okay. And in this slide, just it is, I have given the types of what are the different varieties of graphs which is available in the data structure concept. Okay, the null graph, trivial graph, non-directed graph, directed graph, connected graph, disconnected graph, regular graph, and complete graph, cycle graph, cyclic graph, acyclic graph, finite graph, infinite graph, quadratic graph, planar graph, simple graph, multi-graph, pseudo-graph, Euler graph, or Hamiltonian graph, or biconnected graph. These are all the variety of graph which is available in the data structure concept to collect the data. Okay. In this, the non-directed, directed, connected, disconnected graph and cyclic, acyclic graphs are very, very important graph. Also the Euler graph and the Hamiltonian graph. Okay. Just I have given a undirected graph. Previously we have discussed the directed graph and undirected graph. Okay. Similar way, here also I have given another example for undirected graph. A, B, C, D. All the vertices are connected through edges. Then next one is I have given for the cyclic graph. The cyclic graph means if you start with a vertex A and if you cover all the vertex in the graph and it will ends with the A starting point. It will form a cycle, looping. Okay. So it is given another example. Next one is acyclic graph. You have to cover all the edges, all the vertex in the graph, but you have to travel each edge one time. Okay, but that particular graph, it should not form the cycle. If it forms a cycle, remove that edges from the graph. So that's the concept. Then the Euler graph. The Euler graph is also same. But here also we have to visit all the vertex and you have to use only once, but here it will form a cycle. It's not a problem. But only condition you have to visit each edges only once. The next one is biconnected graph. Biconnected graph is a kind of graph which is used to visit all the nodes in the graph. Okay. If you remove any one vertex from the graph, it should form, again it should be split into a graph alone. Okay. For this case, if I am removing this A, okay, you can consider I am removing this A. Then if I start with B, C, D, E and F, I will end with F. Okay. Even though if you remove any vertex from the graph, again it will form a graph. Okay, this is a concept of biconnected graph. Then why we need this graph concept? The graph, it is used to address the real world problem. That problem, it will be represented as a network, such as telephone network, circuit network, or LinkedIn network, Facebook network, Twitter network. Okay, all the social medias, they are using the graph concept. Okay, that particular real-time problems, it will be represented in two methods. One is sequential representation and another one is linked list representation. The sequential representation, it will use the adjacency matrix, and the linked list representation, it use the adjacency list representation. This is the sequential representation. This sequential representation that already we have discussed that it will use the matrix, adjacency matrix. It will be map the vertices and edges of the graph. Here, if you consider A vertex. A vertex, it is connected with the vertex B and D. So here it is mentioned as 1. The other vertices are mentioned as 0. Likewise, if you consider B, B is connected with A, C and D. A, C, D, the remaining vertex, it is not directly connected with B, so it is mentioned with 0, 0. Okay. Likewise, C, if you consider C is connected with B and E. So B and E alone, it is marked as 1, remaining 0. And next one is E is connected with C and D. CD remaining 0. If you consider D is connected with A, B, E. A, B, E, it is represented. Okay. This is the kind of representation which is used in the sequential method. Okay. The next one is the linked list representation. If I am going with the linked list representation, obviously you know it uses the list concept. Okay. Singular linked list concept it is used. Just it will store your data of graph in the memory. If you consider the A vertex. Okay, A is connected with C, the B and D. So just the A, here I have it has mentioned the vertices alone. A vertices is connected with B, B and D. So it is represented with the help of single linked list. Already you know that linked list, it is having a data field and the address field. Okay. If further node is there, then the address field will be enabled, else it will be marked as null value. Likewise, B, if you consider B, A, D, C. And if you consider C, B and E is connected. And D, A, B, E is connected. And E, D and C is connected. Okay. This is the linked list representation. And this is your reference for this PPT plus the preparation. Thank you. Thank you so much for watching.